Hey guys, Ravi here. Now, most of you would have at least heard of GitHub even if you haven't actually used it. It's this website where everyone and their dog seems to host their code. What many of you might not have heard of is Git. The difference between Git and GitHub is the same as the difference between soccer and a stadium. A stadium isn't necessary to play soccer. Similarly, GitHub is just one place where Git is hosted. You don't need to use it. You can very well run Git on your own machine. But what is Git? Git is the most popular version control system whose main objective is to keep track of your project history. What files have you added? What files have you deleted? And how the content inside those files has changed. I want to say that it is like the undo function on steroids, but that statement doesn't do justice to all that Git enables you to do. Along with version control, Git allows you to make backups, maintain different versions of the same code. It allows you to test and experiment without affecting the actual project. It allows multiple people to work on the same project at the same time, and so much more. We will be exploring some of those features in this video to help you get started. I strongly recommend some kind of version control for anyone who writes more than a couple lines of code. It is easy to use, and believe me, once you get used to it, you would love it more than your firstborn child. Something that I'd like to mention before we get started is that while Git is meant for source code, you can use it to keep track of any file type, images, Word documents, Photoshop projects, etc. It just won't be storage efficient and you won't have all the benefits of Git. Now, let's get started. The first thing you need to do is download and install Git from the link in the description. You can leave all the options to default. When it asks what editor you want to use, I recommend using Visual Studio Code. It has some good built-in integration for version control. Regardless of the editor that you use, you need to install it before you start the Git installation. When the installation has been completed, you'll see two new options in your start menu, Git Bash and Git GUI. Opening Git Bash will open a terminal and you can run Git command to confirm the installation. You don't really ever need to use the Git Bash itself. You can run the same commands in the command prompt or Windows PowerShell or the terminal if you are on Linux or Mac. Now don't be afraid of the terminal if you haven't used it before. It really isn't as difficult or complex as you might think. I'll be using both the terminal and the GUI in this video. Most, if not all, the functionality of Git Bash is available in the GUI. I personally use both for separate purposes. The first thing that you need to do is configure the user's name and email. Open Git Bash and enter these commands. Just enter your own name and email in this place. That done, we can finally start by creating a new repository. You can do this in an existing project folder, but I'm gonna make a new project for this demonstration. A repository is basically the folder that Git would track for any changes. Inside the folder, right-click and select the option Git Bash here. In the terminal, you can see the location of the folder that you just created. To initialize the repository, run the command git init. If the command was executed successfully, a hidden folder named .git would be created. You can also clone an existing repository, but we will come back to that option later. All the commands from here on out that you would be running for this repo need to be run in a terminal that is pointing to this folder. Now, let's try saving something with Git. First, add something to this project. I'll be using VS Code to edit all the files. I'll just be creating text files, but these would usually be source files like .c, .py, .ino, etc. When you have made the changes that you want and have saved the file, we are ready to use Git. Saving something with Git is a bit of an involved process. There are basically two steps: selecting the changes and then committing the selected changes. I'm gonna show you three commands that you'll use the most when you are using Git. These are status, add, and commit. The git status command is used to see the status of the different files in the folder. Running this command shows that the file that we just created is untracked, which means that it won't be saved by Git. So to make Git track it, we need to add it to the staging area. We do this with the git add command. Enter git add followed by the file name. Now if we check the status, it shows that the file is ready to be committed. To commit, we run the git commit command. As soon as you run the command, the editor that you chose during the installation should open up asking for a message. It is very important to enter a message that is meaningful and accurately represents the changes that you are committing. Type the message and then save and close the editor window. You have successfully made your first commit. Pro tip: you can add the commit message from within the terminal without opening any editors by using the -m option. There are a few more ways to make commits instead of using the terminal. The one I use most is from right within VS Code. There is the source control tab on the left that looks like a fork. When you open that, at the top it shows what version control system you are using, and below that you can see the changes that you have made since the last commit. In front of each file you can see three options: open file, disregard changes, and finally stage changes. Click the stage changes button and you are ready to commit. Enter your message in the top and hit Ctrl Enter to commit. Another way to make a commit is through the Git GUI. You can click Open Existing Repository and then browse to the project folder, or just right click in the folder and select Git GUI here. Similar to VS Code, you can see the changes you have made. Click the Stage Changes button, type your message, and then click Commit. After doing that, you might be wondering what is the point of the add command. Why can't we just commit everything directly? Well, you can do that. Just use the -a option with the commit command and all untracked files would be automatically added and committed. So again, the question arises, what's the point of the add command? Well, it is to allow you to commit unrelated changes separately. Let's imagine a scenario. You have optimized a previously added function, but you have also created a new library for something that you will be using in the future. You want to keep these unrelated changes in separate commits so that if you ever wish to undo one of these things, you can do so without affecting the other. More often than not, you will be committing all the changes in the folder at once with the command that I just showed you. But usually, there are files that you don't want in your commits, like temporary files, binary files, log files, or even configuration files generated by the editor. There is no point in tracking changes in these files. Having to add all the files that you have changed one by one just to avoid a single file that you don't want to commit can be a hassle. To avoid this, we can tell Git to permanently ignore some files or folders. This is done by creating a .gitignore file. Inside this file, you can add the things that you don't want Git to see. You can state complete file or folder names that you wish to ignore, or you can use patterns like *.pyc, which would ignore all the files with this extension. I'll leave a link in the description to a table of all the ways you can use patterns in the gitignore file. It's a common practice to add this in the root directory of your project and add it with the first commit. Now, we have reached the point we all knew was coming. You screwed up. Something somewhere went wrong. The feature that you were working on for the last 2 days broke everything, and Ctrl-Z just can't help you anymore. These are the situations Git lives for. There are two primary ways to undo commits in Git: revert and reset. The revert command doesn't actually delete anything. All it does is make a new commit with your selected changes reversed. If you wish to undo the changes of the last commit, just type git revert head. This command will make a new commit with the changes to your latest commit reversed. It gets a little bit trickier if you want to revert an older commit. To do that, first you need to find the ID of the commit that you want to undo. To find this ID, run the command git log one line to see a list of all the commits you have ever made. Each commit is assigned a unique ID. You need to copy the ID of the commit that you wish to undo and run the command git revert followed by the ID that you just copied. Note that all the commits made after the commit that you just reverted will be preserved. Now this is one of the scenarios where I like to use the GUI. Open the GUI by right-clicking in the root folder of the repository. Go to repository, visualize all branch history. In this view, you can clearly see the commit history along with all the changes that you have ever made. You can also see the complete SHA ID here, but you are only interested in the first 7 characters. You can also run the revert command from here by right-clicking a commit and selecting revert this commit. One thing to note is that when you revert an older commit, there is a good chance that it might raise a merge conflict error. We'll see how to deal with those later. Now, what if you want to revert multiple commits? Maybe you want to undo the last 3 commits that you have made. To do that, first copy the ID of the oldest commit that you want to revert and run the command git revert no commit followed by the commit ID you copied ..head. Then run the git commit command. You can open the git log and you'll find that no commit has been deleted. All your history is still there, just the changes of the last 3 commits have been reversed in the latest one. But what if you don't want that history? You have just written such embarrassing code that you want to erase it off the face of the matrix. For that, we use the other undo command. The reset command is a lot more drastic. You can reset your project to any point in the project timeline. But before you run the command, you need to make sure that the commit that you are resetting to is the correct one, because you will be effectively erasing your commit history. One way to confirm the commit is to see the code in the GUI, but that is a limited view and you can't do any testing here. The other method is to run the command git checkout followed by the commit ID. This would change the repository to look like as it looked right after you made the selected commit. You can now run your code, do any changes and testing that you want without any fear of affecting anything. Nothing you do here will be saved. To return back to your latest commit, just run the command git checkout master. Now, once you are sure of the commit that you want to reset to, run the command git reset followed by the commit ID. All the commits after this point will be deleted. Now, there are ways to undo a reset, but I wouldn't treat this command lightly. Also, it is not recommended that you use this command if you regularly push your code to a remote server like GitHub. It can raise errors. I'd recommend sticking to the revert command. Now let's check out one of my favorite features of Git, branches. Branches is a feature that lets you maintain different versions of the same code. As an example, most big projects maintain at least 2 branches, master and development. You can test features in the development branch, and when you have a stable version, it gets pushed to the master branch. What I like to do is pull a branch for every new feature that I want to test, and if it works out, I merge it back into the main branch. If not, then I just abandon the branch. To create a branch from the current commit, run the command git checkout -b followed by the name you wish to assign the branch. You will be now inside the branch that you just created. You can make any changes and commits here without worry. To switch back to your original branch, run the command git checkout master, and you can see you are where you left off. You can even switch between branches from within VS Code by clicking the branch name in the bottom left corner. You can actually create a branch from any commit that you have made in the past by just going to that commit with the checkout command and then running the checkout command with the .b option. The Git GUI is also quite useful here and can help you visualize how the different branches have evolved over time. You can also delete a branch with the command git branch -b followed by the branch name. For my personal projects, I don't delete anything just to keep a history, but you can if you wish to. Now let's say that you have made some changes in 2 separate branches, and now you wish to combine the changes of both into a single branch. You can do this with the merge command. First, go to the branch into which you wish to merge all the changes and then run the command git merge followed by the branch name that you wish to merge into this one. Running this command will more likely than not raise a merge conflict, and the error will tell you to make a commit after resolving it. What Git is saying by this error is that it can't figure out how to merge these 2 different files into a single one by itself and needs your intervention. The way Git allows you to do this is interesting. It changes the actual file itself to indicate the conflict, and it shows you what was the existing file and how the incoming file is gonna change it. All you have to do is change this file and remove the useless bits and make it as you want it to look. Now you can of course do this in any text editor, but if you use an editor that supports Git like VS Code, you'll see some options that allow you to select some potential changes with the press of a single button. You can also see the difference between the two files in a split screen window that allows more easy comparison of the two. Now all you need to do is modify this file to look the way you want. Keep the changes that you want, discard the ones that you don't, and then commit the final product. You can also cancel a merge with the command git merge abort. Now the last thing left to explore is using cloud services like GitHub. GitHub and other services like it such as Bitbucket, SourceForge and others allow you to host your own code on their servers so that other people can access it and contribute to it. It is also a way of maintaining backups. These services usually also provide other additional features that are not present in Git itself, like pull requests, releases, issue trackers, etc. Now downloading code from any of these websites is pretty easy. Just go to the repository that you wish to copy and there is usually a link on that page somewhere that ends with .git. Copy that, open the git bash in a folder where you wish to download the repository and run the command git clone followed by the link that you just copied. Running this command will create a folder with the repository name and it will download all the files in there. Now you can work on this code, make your own changes and commits, but you won't be able to push the changes to the remote server if you don't have access to it. Now, if you wish to create a repository of your own, then first you need to create it on the service website. On GitHub, once you have logged in, there is a plus button in the top right corner. Click that, click Create Repository, give it a name, set it to public or private as you wish, and then click the Create Repository button. It should open a quick setup guide. In here, make sure that you have selected HTTPS and not SSH. From here, you can copy this command. Now, on your computer, either open an existing Git project or create a new one and open git bash there. In here, paste the command that you just copied. Now you are ready to push your code online. Make sure that you have already made at least one commit and then run the command git push -u origin master. It should ask for your login details once and then your code with all the commits that you have ever made will be available online. You would notice that only the master branch is available on GitHub. You need to push separate branches separately. Switch to the dev branch and then run this command again, but replace master with the dev. Now you can see that the dev branch is also available. You only need to do this once when you have created a new repository on GitHub. Afterwards, all you have to do is run the command git push. You can also do this from within VS Code by clicking this button in the bottom left corner. You don't have to run this push command after each commit. Just do it once in a while. Next, suppose that a teammate of yours has pushed some changes to this repository. You can get these changes by running the command git pull. And that is all you need to get started with Git. I know that all of what we have discussed can be a little bit daunting, but believe me, just use Git on your local machine and you will fall in love with it. What I have shown here will be more than enough to help you get started, but there is a lot more to Git than I can fit into a single video. I'll leave some links in the description to some resources that can help you delve a little deeper if you want to learn some more advanced features. I hope this video helped you a little bit, and if it did, make sure to leave a like and I'll see you guys in the next one.